Okay, yeah, I'm doing that from now on. Yeah, well, simple kriging, as the name says, is sort of the simplest of the two methods. Um, with ordinary kriging, you need a bit more information. Um, but basically, what you need to do is to create a function that tells you how the different weights of the weighted average change according to the distance of the points that you're interpolating. Instead of just choosing more or less by intuition, like in IDW, where you just select like a certain power, in kriging, you use a variogram, which is a way in which you can visualize the differences between points at different distances. Um, let's say that we have something like what you can see here. So these are sort of the data points. And like in a lot of geodata sets, you can see that points that are closer together have similar values, and points that are farther away tend to have more different values. And when you decide to plot those differences, so here on the x-axis, you see the distance between the points, and on the y-axis, you have the difference in values. You can see that when points are very close together, they are quite similar. So it starts at close to 0, 0, so the origin, and it sort of goes up as you go farther away. If you compute more or less like how does this happen on average, you will see that the similarity between points, so how different the values of the points are, increases according to the distance and in quite a predictable way. So in a variogram, you can get this measurement for a particular data set, and you can use that to create a function that mimics the differences that you see. This is called a theoretical variogram function, and that's one aspect that you will have to compute in the homework assignment. Let me switch the window here. So yeah, looking at the homework assignment, um, it's a homework that you will have to do in Python, because for this assignment, we're going to use a Python library that's called PyInterpolate. It's a library that is specifically built for kriging. So it does like 80 or 90% of the code that you need is going to be done directly by PyInterpolate, and you will be able to find all the functions that you need in the tutorials. But first of all, you will have to read an input dataset, a raster dataset using Rasterio, which you should have already installed because of homework number 2. So for installation, it's very simple. You can use pip and install PyInterpolate with a pip install, just like you have done that before. In case you need a bit of help on how to read raster datasets with Rasterio, you can just check the Python quick start of Rasterio, and in here you will have all the functions. So how to read the different attributes, the georeferencing, and the data, raster data itself into something like a NumPy array or matrix. Apart from that, in your homework assignment, you will need to make a report. And for that, I expect to see some plots. Most of the plots, you will be able to get them from PyInterpolate itself. But for a few more, you might want to use matplotlib. Specifically within matplotlib, there are two useful functions. There's one scatter for scatter plots, and IMShow, which you can use to show images directly. Yeah, there are a lot of tutorials for these things, and it's all in the description of the homework assignment. For PyInterpolate, it has a lot of good tutorials. my advice is to have a very quick look at the 4 of them, which are listed here. So baryogram point cloud, which tells you how to create a baryogram cloud. Semi-baryogram estimation, which looks at all the different functions that you can use to fit a baryogram function. Ordinary and simple kriging is just executing these two types of kriging directly. And the fourth one is how good is my kriging model, test with IDW algorithm. So PyInterpolate also has an implementation of IDW, and you can, well, you will have to use it for comparing your kriging results. But all of the code is basically in these 4 tutorials. But you still need to select like which parts of the code are useful for you and to adapt them to your own code. For the data, I'm not providing a specific data set, but you should download a 30-meter tile of SRTM, which is a global digital terrain model made from from radar satellite. And yeah, I would advise you to choose something that is not too flat. So the Netherlands is okay, but choose a hilly area at least, because if it's too flat, it will be difficult to see the differences between different values for kriging and IDW, because you can always just feed a plane and everything will look fine otherwise. Yeah, so because SRTM is already data that has been cleaned, so you cannot get access to the raw measurements, you will have to sort of simulate how the raw measurements used to look like. And for that, you will have to add some noise to the points. Also, the SRTM tiles are a bit too large for this assignment, especially since we are using Python for this. So in the assignment, you will have to select 2 samples from the data set. One is a random sample of 1,000 points, which you will treat as the data points, which you will interpolate. And to these ones, you will add the noise that should be normally distributed with a standard deviation of 10 meters on the X and Y axis and 16 meters on the Z axis. I took these values from the SRTM specifications from the satellite, so we can sort of guess what this would have looked like without more processing. And yeah, then you will get another sample, a subset of 10,000 points, and this you will use as a ground truth to compare your interpolation results. So you compute 10,000 random points, which you extract from the SRTM tile. And at the location of those points, you do the interpolation and you compute the value that you get from the interpolation to the value that is stored in the SRTM dataset. And that's how you know whether your interpolation is good or not. I'm asking for some very specific steps here. So you need to visualize both of these datasets first to get a better understanding of them. Here's a simple tip. So because you will have to change the georeferencing of this data set in order to get something that is in a projected CRAs, you will usually get some node data values around the corners because there will be some rotation. So make sure that you don't use the node data values in your input. For the rest, you need to follow more or less the same steps as you see in the kriging lesson. So you need to view the baryogram cloud. You need to create an experimental baryogram. Based on the experimental baryogram, you need to obtain a theoretical baryogram function that fits the dataset. So you need to test different functions and you need to set the parameters for the nugget, the seal, and the range. You need to apply simple kriging using your theoretical baryogram function. You need to apply ordinary kriging, also using your baryogram function. Then you apply IDW. And you compare the results of these 3 methods with respect to the ground truth values. As you will see in the PyInterpolate tutorials, they do test different values for the number of neighbors for kriging and different powers for IDW. So I would advise you to do the same and to see what these parameters change in your results. And as I said, you need to create a report based on what you do. It should be a simple report, and I'm asking for very specific, like 10 items that should be there. Please keep it short. So even though there are 10 items, a lot of these items, or all of the 10 items can be like a very short 1-paragraph description, maybe 1 line of code or 2 lines of code showing the key Python commands that you need to execute, and 1 plot that you can get either from PyInterpolate or from Matplotlib. So the 10 things that you need to incorporate in your report are the part where you reproject the chosen tile, how you create the 1,000 data points with the noise, how you create the 10,000 ground truth points with no noise, the variogram cloud, the experimental variogram, the theoretical variogram function that you fit, the results of doing simple kriging, the results of doing ordinary kriging, the results of IDW, and finally a comparison and analysis of the results. For that, I expect you to use some sort of numerical value. In the tutorials in PyInterpolate, it uses like a root mean square error, but you are free to use something else if you prefer. This report, you and the code, you're going to have to submit it by uploading them to a Dropbox link that is listed in the homework page. And that's basically it. Yeah, if you have any questions, I am here right now. Hugo will be there in person in the labs, and I will be answering questions every day on Discord if you need any help, or if you want to have something more like a video call since I'm away, just let me know and we can schedule that. Yeah, that's basically it.
Okay, thank you. Are there questions? Yes.
I wanted to ask if it's also possible to use other plot libraries than Matplotlib for the additional plots, because I'm, for example, more comfortable with Plotly, and if it's only for the creation of plots, then
did you understand the question, Ken?
Yeah, you can plot with whatever you want. Yeah, Matplotlib is just a suggestion. If you want to use R, it's fine. If you want to use ArcGIS, if you want to export your things and plot them in Excel, yeah, anything that you want for the plots.
Thank you.
Yeah.
Sure.
Can you please explain again about the last part, the comparison?
All right. Sure. Let me share the screen again. So you, in 3 different sections, you will have to describe your results of applying simple kriging, ordinary kriging, and IDW. And in the last section, I'm expecting you to do a comparison analysis of these results. So if you use, for instance, the root mean square error, as is suggested here, and in the PyInterpolate tutorials, I expect to see how the results differ according to the parameters that you have chosen, according to which method. So for instance, if you get better results using kriging, I expect you to say that you got better results using kriging and an explanation for why you think that is the case. If you get better results with IDW, same thing. So say that you got better results with IDW and why you think that is the case for this particular data set. And yeah, that's basically it. I'm not expecting a very in-depth discussion, just which resulted best and why you think it's that way.
It's the book section 5.4 square error for how to compare the interpolation of data. So that's what you should check. Question.
If not, thanks, Ken. You can go to bed. And Yeah, I'm staying here until 10:30 if there's questions about theory, about the assignment, about anything. But you can also go, and I see you next Wednesday. But also Fabian will be always, Fabian is in the lab every Monday, and he will be aware of the assignment, so he can also help with some programming, less with some specific question about if you say, if I answer that, is it okay? Then Fabian will probably not be able to answer. It's more like programming and general help, but you can try. Fabian is also aware of the assignment. Okay, thanks.